Thank you everyone for being here today. My name is Evan Haug, CEO and founder of Leaf Automation, and our mission is to modernize construction engineering using AI-powered automation. Today we're going to be talking about a particular subset of construction, modern power infrastructure, which encapsulates these four design verticals here. And beside growing incredibly quickly, what these all have in common is that they're all power projects at their core, meaning an electrical engineer needs to be designing these projects. 5 years ago, this is where I started my electrical engineering career, designing projects just like these. But last year I left that job to start Leaf to address some of the problems that I saw in the industry. And that problem is an engineering labor shortage. Currently, the US is awarding fewer and fewer of the electrical engineering degrees it takes to build and design these power infrastructure projects, leading to what Boston Consulting Group has reported to be 33% of new engineering roles going unfilled in the industry, resulting in over $2 billion per year in unrealized profits for these engineering companies. Trying to fill this engineering labor shortage with more people is going to be timely and expensive. But at Leaf, we believe we can use artificial intelligence to artificially fill this engineering labor gap by making the existing workforce more productive designers. But there's a problem with that because existing AI models just aren't suited for engineering automation. LLMs, for example, ChatGPT will even tell you that they lack the precise technical calculations and spatial awareness to automate these engineering systems. And generative AI is similarly problematic. A single input will always generate two very different outputs, which is a problem for engineering, which is both deterministic and finite. So what do you do when you can't rely on an open source AI model? You build your own. We built Arlo, a custom-built AI model for engineering automation, which stands for Agent-Based Reinforcement Learning Optimization. It has that spatial vision to be able to navigate an engineering environment, especially inside of a CAD tool. It is self-learning, meaning we don't have to go out into the industry and procure tons of industry data, clean all of that, and use that to train our models. We can do it all without data. And best of all, it's flexible. If you look down here at this model, all it takes to train our Arlo model is a design optimization objective function and some code compliance guardrails to constrain that solution space. And we can plug anything into that to really automate any sort of engineering design task. And we've started with solar engineering. So if we take a look at this example project here, it might take an engineer about 40 hours to design a 2 megawatt solar project by taking these basic engineering inputs and translating them into a completed design inside of a CAD platform like AutoCAD. That's why we developed Branch. It's a CAD-based plugin that integrates directly into AutoCAD, completely bypassing all of this manual engineering work by taking just a few minutes to prepare these engineering inputs and generating results in seconds. Let me show you what I mean. This is real-time footage of an engineer designing a solar project here. He's hand counting each one of these solar panels and using the line tool to indicate which one of them will be electrically connected. He's going to repeat this process between 500 and 1,000 times before this project is over, and Branch completely automates this work. Using Branch is as simple as just opening up a project as you would any other, but where we're different here is you can actually specify the type of hardware you're using, and Branch will automatically calculate all the engineering figures you need to move on to the next steps. And so this then gets forwarded into our AI to complete a fully optimized electrical design there in just seconds. And then all it takes to export the wiring is to just drop in a couple more pieces of hardware, and Branch extracts all of that information out of the drawing and puts it nicely into an Excel spreadsheet for the engineer. Just to drive this point home, here's a head-to-head example of Branch versus a human engineer. You can see here they're completing the same exact project, but based on the timer at the bottom, it takes just a fraction of the time for Branch to automate this entire engineering design, whereas it takes about 30 minutes for the engineer, and projects can get about 100 times larger than this. A huge time sink for engineers. So the value proposition for Branch is threefold. First is reduced project costs. Between the engineering labor, the labor out in the field, and the optimizations for the hardware CapEx that we're providing, Branch is projected to add an additional 11% to the margins of each individual project. Two, improve performance, meaning that engineering teams can move through more projects more quickly with fewer errors, directly taking on that engineering labor shortage and providing a value of about $30,000 per engineer per year. And finally, fast design simulation. Never before has an engineer been able to easily make adjustments, compare different design configurations, or quickly estimate for purchasing, but with Branch, all of that is now possible, maximizing efficiency across the board. Companies in the industry are very excited about these value propositions, thanks in part to a couple of awards we've received from the Department of Energy over the last 12 months. We've signed contracts with 4 of the top 10 U.S. solar engineering firms, 10 companies in total, representing 250 end users that we'll be deploying our pilot to here at the end of June, and we're hoping to start converting those into sales by Q4 of this year. After we convert all of our pilots, the way we generate more sales is a little bit unconventional. We'll exhibit at trade shows where we can talk to C-suite and decision makers in these organizations, and we'll go direct to end user with free trials. You might say that that's a little bit of a slow approach, but this strategy is strategic because we want to form long-lasting and intimate relationships with these companies that we can leverage for sales down the line, because Branch and solar engineering is just the start. We plan to take our Arlo technology and horizontally diversify it across all sorts of engineering verticals. And here's a quick look at our product roadmap. We start with Branch, and then we move into EV charging with Branch EV, and then finally with Roots, that'll be data centers. It'll take a little bit of R&D to take what we're doing in 2D and take it into 3D. But then after that, we move into other disciplines, including mechanical, structural, and civil engineering. But keeping the market look at the short-term disciplines here, these 4 design opportunities represent about $3.7 billion in design revenue opportunity globally, $1.1 billion for our beachhead with solar, and totaling about $8.5 billion by 2030, growing at a pretty great pace there. So here's the team behind all of this technology. Besides being our CEO, I'm our engineering and CAD expert, having spent 5 years in the industry. Vikram is our AI lead and PhD at the University of Cambridge, and the brains behind our Arlo model. Ben and Jake are our full stack software developers with a combined 8 years in enterprise software development experience. And Cooper rounds out our highly technical team with his experience as a Deloitte technology consultant. And we are financially backed by Case Western, the University of Chicago, and the Department of Energy. Right now we're seeking to raise $1 million for our pre-seed rounds for 18 months of runway to develop our current products and future products and bring our founders on full time to do that. Acceleration by bringing our product to market even more quickly so we can get to revenue even faster. And research to take what we're doing in 2 dimensions with our Arlo technology and taking that into the 3rd dimension. So, in conclusion, at Leaf Automation, we are taking on the engineering labor shortage in construction engineering, and we've done that by developing our own proprietary AI model, Arlo, which is scalable across engineering verticals, and the first application of that is Branch, a solar engineering plugin that has a ton of early traction, implying that we could be short-term profitable. So today we are seeking investment to help bring Leaf to revenue and begin work on our future products. Thank you.